Hello, Dr. Rose. This is Boniface Masaba, going to present to you my coursework about Paraview. Today, I'm going to focus on MRI and the CT scan dataset that I downloaded from a GitHub source. Now, my research has brought to a conclusion that Paraview is highly preferred for scientific visualization, and MRI and CT scan datasets are a perfect example of data that has been produced as a result of scientific activities. How much better to get wisdom than gold, to get insight rather than silver. This is my word of encouragement or wisdom today. What is Paraview? Paraview is an open source, scalable, multi-platform visualization application. Paraview is a free interactive visualization package produced by Kitware, and it's built upon the VTK toolkit. This is the data flow for Paraview. You have the data sources which arrive from maybe files, and then it's filtered in through numerous algorithms and then sent to sinks. Okay, and then it's also important to know that Paraview has the graphic user interface and also the, the scripting interface. So there are many data types. One of them is the uniform rectilinear. We have the non-uniform rectilinear, the curvilinear, the polygonal, and the unstructured, among others. These are the data types that are compatible with Paraview. Why do we do visualization? Because to visualize patterns, it's easy to get patterns and relationships. It is easy to share information. It's also interactive and explore opportunities. Yes, and that's why we use visualization. So there are many types of visualizations or categories. Some books are calling it taxonomies. So the first one is the scientific visualization or SciVis. We have also the information visualization, the InfoVis, and then visual analytics. We're going to focus on the scientific visualization, which deals with all aspects that the visual representation of data sets from scientific experiments or simulations to achieve better understanding of simpler presentation of complex phenomena. Let me go back a bit. So scientific visualization, data with implicit or explicit geometric structure. So for example, measurements, results from simulations or experiments, anything that has real physical attachment. Scientific is considered scientific visualization. For this project, aims to get familiar with different visualization techniques commonly used in scientific visualization, including volume rendering, ISO surfaces, and glyphs visualization using Paraview. In this project also we are going to use CT scan and MRI datasets. These two datasets will be loaded to Paraview and different visualizations will be performed, including volume rendering and slicing and clipping. So here is a detail about information visualization, and then we have also the visual analytics. You can read about the summaries of the various visualization taxonomies. As I said, we have the scientific, we have the information, we have the info. There are many. You'll find out. So there are also a number of visualization softwares available. We have the commercial ones, we have the open source. The open source includes the Paraview and many others. The commercial ones include I saw Tableau here. We have Tableau and Power BI, which we are familiar with. So for this is our sort of program of what we're going to do. For the dataset 1, we're going to learn how to use Paraview to visualize the brain MRI data. And then for dataset 2, we're going to learn how to use Paraview to visualize head CT scan dataset. So this is the program structure for this presentation. So dataset 1, the dataset name is brain.vtk. Its link is here. This is where you go to the dataset, and the description is brain MRI, and the dataset size is that one, 694. All right. So our first activity is volume rendering. See, so the first activity will be volume rendering. Okay, volume rendering is a technique used in scientific visualization to represent three-dimensional data where the interior of the object is also visualized rather than just its surface. Unlike surface rendering, which only shows the outermost boundaries, volume rendering involves displaying the entire volume of data by calculating the interior interaction of light with the material in the volume. With volume rendering, a solid mesh is rendered. It is like a translucent cloud. It uses the scalar field to determine the color and density. The steps are here. Reset Paraview to default. Open the dataset file and click Apply. Change the representation to volume. Respond yes to the dialog box warning you about the change to the volume. So first we need to upload our data to Paraview. So we go to the file icon and search for brain.vtk and then click OK. Click OK, and then our brain.vtk dataset will be uploaded into Paraview. You see that there's nothing here for now until we click Apply. When you click Apply, it shows that this is an outline in this drop down menu. So we have an outline. What else? We change this outline into a volume because our focus is on volume rendering. So we look for volume and then we click yes, we accept the changes, and voila, this is what we are going to see, our volume rendering. So our next activity is slicing. Slicing allows one to focus on one slice of 3D visualization around digging in. Steps start from visualization in patch 1.1, the rendered volume, then click on the slice icon, move the slicing plate to the election location and then click apply. So what you're going to do is going to this and then we click apply, slice, then apply, then we slice our, our volume rendering. So this is exactly what's happening. We are going to drag this to the position, the plate, to the position where we want, and then we click apply. Okay, but to get here we have to choose this icon called slice. Okay, now after we have clicked on that, this is what comes up, and then we click apply, and then this is the result, slice of the original piece. So again, we're going to do another activity on the dataset 2, the head sq.vti. That's the name of our dataset. So using Paraview to analyze the head CT scan dataset. What we're going to do here is a contour filter. Contour filter computes isolines and isosurfaces using a selected point-centered scalar array. Steps: open dataset sq.vti. So we're going to open our dataset and then click on the apply button. The outline of the visualization shows up, and then click on the filter and then look for the contour filter, and then we click apply. So just like the way we uploaded the brain.vtk, we're also going to do the head sq.vtk, and then okay, then we're going to have that. So but sometimes the filters are not available, the menu is here, so you search for the filter in the filter menu, then click search and then type the word contour. The contour word will come here, click on it or press enter, and then click apply. You see a different rendering. So we're going to learn how to do clipping. Clipping allows cutting a portion of the 3D image and looking inside. This action will enable the user to see the bones from the inside. Step 1 is we go back to the contoured, this one, and this is the one we're going to use, and then we cut it into half. So this is, so here we're going to look for the icon for clipping. Right here in the corner, I put the arrow, and then a ring and a plate will come around it. We move this to a position we want, and we click apply, and you can see that we have it in half. For this exercise, I have not really focused much on the colors and trying to beautify things. I'm using the standard. Okay, so we're going to learn how to save our work on the state. So to save the state, we go to the file menu, top menu, and then we click save state, and this pop-up will come up to show us where we can save the product, the file, and then you have to give the file name and then click OK. Next, we are going to learn how to disconnect. Okay, to disconnect, again you need to go to file and click disconnect. We're going to learn how to reset to default. Okay, in case you have made changes and then you don't want and you want the default changes, the default settings that came with the software, you go to edit, look for reset to default settings. Okay, this is very important. So in case you want to load the information that you've just been working on, or load state, okay, we go back again to file, look for load state. What will come is the file name will come up, and then you choose, if there are many here, you choose the one that you want and click OK. Here are some of the references and the materials that I used to learn how to use Paraview. Thank you for listening. Have a great day.